Alright, for today's integral, we have the integral of x minus 1 to the power of ln x plus 1 over x plus 1 to the ln x minus 1 dx. Now this integral looks a bit wonky. There's no nice u sub, there's no, by parts isn't going to do anything, that'd be horrible. There's no partial fractions, there's no trig, so none of our base techniques work. However, we can manipulate this using a formula we know, being that let's just take something like f of x. F of x can be rewritten as e to the ln of f of x. We know that e to the power of ln something is just going to give us return what's inside the ln, because the e and the ln's cancel, whatever. So using this property, we are going to rewrite our integrand. Now, we're going to rewrite our x minus 1 in the numerator and our x plus 1 in the denominator using this. So x minus 1 we're going to rewrite as e to the ln of x minus 1. And now this whole thing is going to be raised to the ln of x plus 1 now. In the denominator, really similar process. We're going to rewrite x plus 1 as e to the ln of x plus 1. That's all going to be raised to the power of the ln of x minus 1 dx. Now another exponent property you might remember is that let's call it x this time. If we had x to the power of a, and that's all raised to the power of b, that is equal to x to the power of a times b. So now, using that property, we're going to work with our integrand again. Now, e to the ln x minus 1 is going to, or e is our thing that was x in the formula. Our a is going to be ln of x minus 1, and our b is going to be ln of x plus 1. So using that formula, we're going to rewrite this as e to the ln of x minus 1 times ln of x plus 1. Denominator, really similar, e to the ln of x plus 1 times ln of x minus 1. Yeah, times x minus 1. Sorry, I was looking at the wrong part. Yeah. So, yeah. We're going to be left with integral of e to the ln x minus 1 times ln x plus 1 over e to the ln x plus 1 times ln x minus 1. And what we want to notice here is that while the ln's are swapped, they're being multiplied together, so that doesn't matter, and both the numerator and denominator are exactly the same. So because of that, we just cancel that, and that's just going to turn into an integral of 1 dx. Therefore, we're going to be left with x plus c. And that is our final answer.